All right, so welcome to tonight's lesson. We're still discussing binomial theorem, and we're still under the introduction, though today we're going to go a bit in details. Yeah, so let's quickly see what we have tonight. So these are the contacts that you can use to reach me in case you need lessons or in case you need anything to do with mathematics or physics, or if you have questions or assignments, you can simply reach me using these same lines. All right, so we're going to proceed from where we ended. So this is the question where we're going to start from. There are also those questions that require us to prove, which have skipped. And I think if I'll not make tutorial videos, they are very long questions. If I start solving one, maybe I might even end up finishing the whole session just solving one or two questions. So I decided that we can solve these short questions together. And then if it means solving those together, we can solve them at the end when we're done with the tutorial sheet. All right, so let me quickly start solving the questions. Okay. Okay, so we have this question here. It says, which says use the binomial theorem to expand the following functions. So the most important thing about the binomial theorem is to know the formula and what everything in the formula means. So in the previous lesson, I taught on the combinations. So if you want to know how to simplify combinations, you can simply just inbox me. You can tell me to do assist to, you can tell me to send you the video. Yeah, and we see how much we can help each other. I'm going to send you the link so that you watch and know how to deal with combinations. All right, so the combinations are very important to binomial. So the formula for finding the nth term in the theorem, using the theorem in binomial, you simply say the nth term is equal to n choose r. So this r in some books they use k. And then we say a, sometimes where there's a, they use x. Then we say n minus r, then times b to the power r. So where there's a and b, some books they use x and y. But because we have x and y in the, x in the questions, I've decided to use a and b. Then when there's r in some books, they use k. Okay, so let's quickly begin to solve the questions. So we've been given the first question there, which is 1/2 plus 2/3 x. So how do we expand that using the binomial? So we are expanding 1/2 plus 2/3 x to the power 4. So the first term, so this is the nth term. So the first term, the value of n doesn't change. So the value of n there is 4. And then the first value of r that we start with is what? Is 0. So we start with n choose 0. And then we have the value of a. The value of a, if you have any term, or maybe before I write the expansion, let me write an expression for the theorem. Yeah, so this one is used to find the nth term in the theorem. Now let's see how we can expand this function a plus b to the power n. So the first thing that you do is you say n choose what? Choose 0, and then you say n minus 0, that will give us what? 0, and then b to the power what? 0. Then the second term will be n choose 1, and then this will be a n minus 1 b to the power what? 1. So whatever you have as the value of r there is what you have as the power of b. And then you keep on subtracting 1 from the power of n there. So we have another term which is n choose 2, and then we have a n minus 2, then b to the power 2. Then you have the other term until you reach n choose what? N. Yeah, so this is going to be the last term. And then you have n minus n, which is simply just going to give you what? 0. So n minus n will give you 0. So this is going to be a to the power 0 and then b to the power what? N. So this is the general formula for the binomial theorem. Let us now begin to put in the values that we've been given there. So the value of a that we have is half. The value of b is 1 over 3x. And then the value of n is simply just 4. So we have 1 over 2 plus 2 over 3. So these are some of the videos that counting to be the last videos that I'm posting on the channel for free. So the next videos, this week is going to be the last time I'm going to be posting videos on my channel, and the videos being accessible by everyone. So starting from next week, only those that have joined my tuitions will be able to access these videos that I'm going to be posting. Yeah, so there's a way that we hide things on YouTube. It's not all the videos that everyone can see on YouTube. There are some videos which have hidden. Only those in respective universities see them. Okay, so the value of n is 4. So that is what I'm also going to do for UNZA. So those that have not yet joined my tuitions, make sure that you join this week, so that starting from next week, you can also have access to all the videos that I'll be posting. Yeah, so let's quickly continue. So the first value of, the first combination that we have there is n, which is 4, choose 0. And then the value of a is half there. So we put our half to the power what? N, which is 4 minus 0. Okay, sorry, the first one should just have 4, n, which is 4. Yeah, 4 minus 0 is actually 4. And then b there that we have is 2 over 3x. So we put 2 over 3x. Okay, and then this is to the power 0. And we have the next term there will be n, which is 4, choose 1. And then we have a, which is half to the power n minus 1. So we say 4 minus 1, which is 3. And then there we have 2 over 3 x, 2 over 3x to the power 1. Then the next term will be 4, choose 2. Then we have 1 over 2 raised to the power 4 minus 2. This will give us 2. And then we have 2 over 3x raised to the power what? 2. And then we have the other term, which is 4, choose 3. And we have 1 over 2 raised to the power 4 minus 3. This is 1. And then the power there will be, here we have 2 over 3x to the power 3. And then the last term is going to be 4, choose 4. And then we have half to the power what? To the power 0, because we know that 4 minus 4 will give us what? 0. And then we have 2 over 3x raised to the power what? 4. So here it's just a matter of simplifying the expressions that we have, which I believe everyone can do. But let me just help you to simplify the coefficients, which is the combinations. Or I think I'll just finish it up. Let me finish it up. So we have 4, choose 0. 4, choose 0 is simply just, so I'll be doing the combinations here. Yeah. So we have 4, choose 0. 4, choose 0 is simply just 4 factorial over 0 factorial, then open brackets 4 minus 0 factorial. Because we know that the formula for combination is n choose r is equal to n factorial over r factorial. And then we have n minus r factorial. So this is what we have. So on top there, we're going to have 4 factorial over the denominator. 0 factorial is 1. And 4 minus 0 will give us what? 4 factorial. So this will give us 1. So this part here gives us 1. Then 1 to the power 1 over 2 to the power 4 will give me 1 over 16. I have 1 over 16 there. Then I'm multiplying this with 1 over 2. 2 over 3 to the time. X to the power 0 is simply just 1. So the first term there will be 1 times 2 over 1 times 1 over 16. So that is my first term. Oh, sorry. Okay. Oh, sorry for that. Okay. All right, so we have this. And then this is our first term. Move on to the second term. So we're done with this part. Move on to this part. 4 choose 1 is also going to give us, so 4 choose 1 gives us what? So 4 choose 1 will give us 4. Okay, let us solve it here together so that you know what I'm talking about. 4 choose 1, we have 1 there. This will be 4 factorial over 1 factorial, 1 factorial, and then open brackets 4 minus 1 factorial. And this will give us 4 times 3 factorial over 1 factorial is 1. 4 minus 1 is going to give us 3 factorial there. So that and that cancels. 4 times 1 here, it will give us 4. So we have this part gives us what? 4. And then this one will give us 1 over 8. And this part will give us 2 over 3x. Then we say plus. We are done with this one. We move on to this one. So 4 choose 2. So 4 choose 2 is also simple. Yeah, so like I said, starting from next week, the videos will only be accessible to those people that have joined my lessons. Yeah, so not everyone will be able to access the videos on YouTube. Okay, so 4 choose, we're trying to solve 4 choose 2 here. So we have 4 choose 2 there. And 4 choose 2 be simplified as 4 factorial following this formula there. This one is R, 4 factorial over, we have 2 factorial, then 4 minus 2 factorial. And this will give us what? 4 times 3 times 2 factorial. Then we have 2 factorial there. Then we also have another 2 factorial. So 1 2 factorial cancel with 1 2 factorial. Then we have 4 times 3. This will give us what? 12 over 2 factorial, that is 2. So this will give us 6. So we have 6 there. And then 1 over 2 to the power 2, this will give us 1 over 4. And 2 over 3 to the power 2, this will give us 2 over 3, 2 to the power 2 will give us 4, 3 to the power 2 will give us 9, and then x to the power 2 will give us x to the power 2. And then we move on to the other term, which is this one. So we have 4 choose 3 there. So 4 choose 3. So 4 choose 3 is going to be equal to, so we say 4 factorial over 3 factorial, and then 4 minus 3 factorial. So this is going to be equal to 4 times 3 factorial, then everything divided by 3 factorial. 4 minus 3 will give us what? 1 factorial. So 3 and 3 will cancel. 1 factorial is 1. 4 times 1 will give us what? 4 over 1, which is 4. So this will also give us 4. And this will also give us 4. And 1 over 2 to the power 1 will give us what? 1 over 2. And then 2 over 3 to the power 3 will give us 2 to the power 3 is 8. 3 to the power 3 gives us what? 27. And then x to the power 3. Then we move on to the last term. So we are done with this one. 4 choose 4. This will give us what? Let us do it together here. Okay. So 4 choose 4. We have 4 factorial there over 4 factorial. And we have 4 minus 4 factorial. So this will be 4 factorial, this 4 factorial and that 4 factorial will cancel. So we're just going to remain with 1 on top. Then 4 minus 4, this is 0 factorial. 0 factorial is 1. 1 over 1, the answer is 1. So we have, this part gives us what? 1. Then we'll multiply with half to the power 0, 1, and 2 to the power 4, we're getting what? We're getting 16, and then 3 to the power 4, we're getting what? 81. So we have x to the power 4. So here's just a matter of simplifying, which I believe everyone can do. So the first term is 1 over 16 plus, this one will give us 1 over 2 times 2 over 3. This will give us 1 over 3x. And this one will give us 3 over 2. So 3 over 2 will give us 2 over 3 here. So we're getting 2 over 3 x squared. Is it 2 over 3? 4 and 4 will cancel. Yes, 2 over 3. And then we move on to this term. This term we have 4 here, then we have 2 there. So we have 2 there and 2, 4. This will give us 2 times 8. So 2 times 8 will give us what? 16. So we have 16 over 27 x to the power 3. And then this one will give us 16 over 81. So we have 16 over 81 x to the power 4. So this is the expansion for the first question there. Yeah, so this is how you expand using the binomial theorem. Let's quickly move on to the next one. So like I said, next week, starting from next week, only those that have paid for tuitions will be able to access the lessons. The others will not be able to see the lessons. So this is what we have. So even this one will do the same. So if you don't want to, if you don't want to be writing a lot of things, you can just be saying the first term there to the power what n that you have, then followed by the first term raised to the power n, and then followed by the second term. The second term will be the first term raised to the power 3. The first term raised to the power 3, and then the second term there raised to the power what? Okay, let me not confuse you. Let me just use what you know. Because you can start, this one is increasing, this one is reducing. And as you are doing that, you also include the combinations. So if you have one there, it's very easy. But I'll come and show you using the extension, because when I introduce it now, you get confused. Let me just follow what you know. Yeah, there's what is known as the extension, the binomial extension, the one that you use to expand something like this, the one that you use to expand any fraction, any function that is in the fraction, or any radical, or any binomial expansion that is in the form, or that has a negative power, or any binomial expansion that has the fraction, the rational power. So you can use the extension to expand this, that, or that, or something like this. So you can use the extension to expand this, that, or to expand the root of, or rather to find the solution of, to find the solution of 0.0021 to the power, sorry, there should be something here, 1.00221 to the power 3. They ask you to find this without using a calculator. You can use binomial to find this, 1.37 to the power 5. You can also use binomial to find the solution for this, the approximate solution, of course. So we're going to learn all these things when we learn how to use the extension. And the extension only applies when you have one there. So we're going to know how to change everything into this format. So it's very simple. Okay, so make sure that you also tell those that have not yet joined the lessons to also be part of us. So we have 1 minus 8x to the power 5. Then we're expanding this. So the first term we have 5 choose 0. And then we have 1 to the power what? 1 to the power 5. And negative 8x to the power 0. And then we move on to the first one, to the next one. The next one will be 5 choose 1. Then we have 1. So if you have 1 there, if you have 1 as the first, as the value of a, because 1 to the power 5 will give you 1, 1 to the power 4 will give you 1, 1 to the power 3 will give you 1, 1 to the power what, it will still be 1. So you can even be leaving it out. You can just be getting this part and the part for the combination. So let's do that, because 1 to the power 4 here, 1 to the power 5 will give us 1, 1 to the power 4 will give us 1, 1 to the power 3 will give us 1, 1 to the power 2 will give us 1, 1 to the power 1 will give us 1, 1 to the power 0 will give us 1. So that's the same as leaving it out. So you just have to include it on the first, on the first term, you just say 1 to the power 5. Okay, for the sake of understanding, I like treating everyone like as if you don't know anything, but you know what I'm talking about. It's important to do that because not everyone knows everything. There's some people who are simply just learning this for the first time. So we have 5 choose 0, and then 1 to the power 5. 5 choose 1, 1 to the power 4. And then we have negative 8x to the power 1. And then we have 5 choose 2, 1 to the power 3. Then we have negative 8x to the power 2. Then we have 5 choose 2 to the power, 1 to the power 3. Then we, oh, sorry, this is 5 choose 1, 2, this is 5 choose 3. So that we have 1 to the power 2 then. Then we have negative 8x to the power 3. Then we have 5 choose 4 to the power, 1 to the power 2 to the power 1. Then we have negative 8x to the power negative 8x to the power 4. And then the last term, you just get what is there. So we have negative 8x to the power 5. So the first term is always what is there to the power 5. The last term will be always what is here to the power 5. So this is why I said the first term there, you can just write 1 to the power 5, which is just 1. And then the next term here, you simply say 5 choose 1. It gives us what? 5. Yeah, so 5 choose 1 will give us 5. And we're going to have 5 times, we're going to have 5 times what? Times negative 8x. That will give us, okay, let me just say plus 5 times negative 8x. And we have another term there, which is the third term there, 5 choose 2. So we write our 5 choose 2 there, find our 5 choose 2. So 5 choose 2 can also be written as 2 times 1. Remember the short form I taught you to solve choose mean combinations. So we first write what is down, 2 times 1, and okay, so this is how you find the combinations. So we move on to the next one. The next one is, oh, sorry, I was talking about how you find the combination here. So you first write what is down, 2 times 1, then on top you're going to say 5 times 4. So 5 times 4, you have 2 there, 1, 2 there, 2. 2 times 5 to give us what? 10. So write our 10 there. And then we have, this is 8 to the power, negative 8 to the power 2. So 8 to the power 2 will give us what? 64. So this will give us 64. And then 8 to the power 2 will give us 64. Then we have x to the power what? To the power 2. And then the other term is 5 choose 3. So 5 choose 3, we also use the short form of solving combinations. So the short form is you write what is down. So there we have 3. So we write 3 times 2 times 1. Then on top, we follow the number of numbers down there is the number of numbers that is supposed to be up. So we have 5 times 4 times 3. So we end there. So we have 3 and 3 cancelling. 2 into 4, the answer is 2. 2 times 5, the answer is 10 there. So we write our 10 there. And then we have 8 to the power 3. So we have 8 times 8 times 8. Okay, so for the sake of time, it's already counting down. Let me just write 8 to the power 3. And then we have 8 to the power 3. Let me do it this way. So we have 8 to the power 3, x to the power what? 3 as well. That's that I don't have my calculator anywhere near me. I would have been finding that. But in an exam, you just calculate using a paper. So you say 8 times 8, 64. 64 times 8, say 8 times 4. The answer is 32, 2 remainder 3. 8 times 6, the answer is 48, 49, 50, 51. So the answer is 512 there. So in case you didn't know, that's the shortest form. That's the way you multiply numbers. Okay, so this is what we have, and then we move on to the next one. So this one is supposed to be negative because the power is an odd number there. So the 512 is supposed to be negative 512. So negative 512. So we move on to the next one. 5 choose 4. The answer is also 5. So we have 5. If you want to prove, you can say over. Then you have 4 times 3 times 2 times 1. Then you have 5 times 4 times 3 times 1. You can see that that will cancel with that. This will cancel with, wait, we're trying to find what? Oh, there's supposed to be 2 there. Okay, 5 times, this is canceling with that, that with that, that with that. You're just remaining with 5 and 1 there. So that's why it's 5. And then negative 8 to the power 4. So we have 512 to the power times 8 again. So 8 times 2 will give us 16, remainder 1. 8 times 1, 8 plus 1, 9. 8 times 5, 40. So this is what you have, 40, 96. And you have x to the power 4. Then the last one will be 8 to the power 5. So we expect that to be a negative number. So we have, because the power is an odd number. So we are going to have negative 8. We're going to have the same answer that we've gotten here times what? Times 8. So we have 96 times 8. 8 times 6, 48. Remainder, so we have 4 remainder 8, and then we have 8 times 8 times 9 will give us what? 8 times 9 gives us 72. 72 plus 72 plus the 4 which remained here. So we have 76, we write 6, remainder 7. 8 times 0, 0 plus 7, that will be a 7. 8 times 4, the answer is 32. So we have 3, 2, 7, 6, 8. Yeah, so that's what we have there. So we have negative 3, 2, 7, 6, 8. Then you just simplify the whole expression down here. So the first term is 1. The next term is 5 times 4, 5 times negative 8 rather. That will be negative 40x. And then we have 10 times 64. That is 640 x squared. Then we have 10 times negative 512. We have negative 5,120 x to the power 3. Then we have 5 times 40, 96. 5 times 6, 30, 0, remainder 3. 5 times 9, 45, 45, 46, 47, 48. So 8, remainder 4. 5 times 0, 0 plus 4. We have 4. Then 5 times 4, we are getting 20. So we have 20, 0, 4. We have positive 20. And then we have 4, 8, 0. Then x to the power 4. Then the last digit there, the last number rather, is negative 3, 2, 7, 6, 8. So this is the expansion for this binomial that we've been given there, for that function that we've been given there. All right, so this is very simple. So I believe the same way I've solved this one, you can also solve part C. So looking at time, I think you guys, you're going to solve C. I don't usually give you exercises. I want you to solve C and then send me the solution on WhatsApp. Let me see how you're going to solve it. Yeah, so let's quickly join using the same link so that we solve at least another question before the time elapses. So let's move on to the next question. So I'm ending the link right now. Make sure that you join using the same link so that we finish up the remaining question.